Alright, so we're going to talk about how to determine if your answers for your question, okay, on Maclaurin expansion are correct, okay, during a test or an exam. So over here you see an example which you talked about in some other video lessons, and what if this is your solution, okay, that you have done up? This is your answers in your test. This is your answer in an exam. How do you know for sure that this is correct, right? I mean, in an assignment, usually sometimes you have access to the final answer. You can actually check that, but in exams, you want to secure as many points as possible. So, how do you know for sure? Now, I'm going to teach you a very simple way to do that, okay? So what's going to happen is that all you need to do is to use a value of x that is sufficiently small, okay? You need to use a very small number, and some of you may ask why, but that answer to this question will be answered in some other videos because I want to show you diagrams, okay, to illustrate and to answer that clearly. So we're not going to touch on that in this video, but over here our focus is about learning how to check whether our answers is correct or not, okay? So just remember this, you're gonna make sure that you choose a relatively small x, and in this case I usually like to use 0.1, but we can also go even further down to 0.01, okay? So let's say we choose 0.01, okay? Now what we're gonna do here is that we're gonna key in the value of x equals 0.01 into the original equation, okay, which is cosine 2x over 1 minus sine x. We are also going to substitute that value of x into our final answer, and we want to see if both of these answers tally, okay? So let's go ahead and work that out for the actual value, which is this. Now, what you need to remember is that when you're dealing with trigonometries in questions like this, make sure that you change your calculator, your scientific calculator, or your GC into radian mode, okay, if it's not already in radian mode, okay, because all these x's over here are in radian mode, all right? Now, let's go ahead and press this into a calculator. So we have cosine, okay, 2 times 0.01 is just 0.02, okay? Now next up we have 1 minus sine 0.01. Okay, let's press our calculator and we get 1.0098988827. All right, you can actually change this to 5SF if you want to. I'm just copying what I have from my calculator over here. Now, what we need to do next is to go figure out what is the value of 1 plus x, which is 0.01. Okay, 0.01. Then minus 0.01 square, which is x squared, minus 19 over 6, 0.01 cube. Okay, so let's go ahead and press that into our calculator. We have 1 plus 0.01 minus 0.01 square minus 19 over 6, 0.01 cube. Okay, so let's see what is the value. Okay, equal, and we get 1.0098986833. All right, so we see that there's some errors over here, and that's fine, okay? Because if you were to look at just the first 6 digits or 5 decimal places, they are exactly the same, okay? And remember, the reason why they're different is because there is the plus dot dot dot, which we did not specify what it was, okay? So the value over here, where we have dropped the plus dot 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 at the back, is actually an estimation of the actual value. So when you have key in 0.01, all right, and you see that you have the digits at the front, okay, and in this case is actually pretty accurate up to 5 decimal places, 1.00989, okay, it's the same, all right, for both of these workings, okay, for both of these workings, then you know that you have actually gotten the correct answer.